Now we're going to look at generating the hyperbolic sine and cosine functions using the CORDIC algorithm. Now we're going to use the hyperbolic in rotation mode, and we'll use the same process that we did whenever we worked out the simple sine and cosine functions. So if you'd like, you can go back to the previous video whenever we generated the sine and the cosine function, and you can have a look at that as a reminder. Now we're going through the same process, but we're doing it with the hyperbolic functions. So we have the CORDIC algorithm, the initialization and the output. So the CORDIC algorithm is the same CORDIC algorithm that we've seen for the hyperbolics. The only difference is now we're using it in rotation mode. So we're now comparing the angles as opposed to comparing the lengths. So this little section here has changed. Previously we would be in the vectoring mode, we would be using the terms yji instead of the zji. But now we're in the rotation mode, so we're going to be comparing these angles. So don't worry too much, we're going to have a look at it in the graphical calculator and it'll all become clear. Now whenever we set up the initialization, what we want to do is set the value for x0 to 1 upon an. Now remember, our an is generated from this algorithm here, and in the hyperbolics the value is approximately equal to 0.82816. So we're going to set x0 to 1 upon an, which is our value k, and we can call that as a value of 1.20749. We're also going to set the y0 as a value of 0, and we're going to set the input angle z0 to the angle theta. So in effect, this is the input angle that we're putting in, and we want to work out the cos and the sine of this angle theta. Now whenever we work through the CORDIC algorithm, our output xn will tend towards the cos of theta, yn will tend towards the sine of theta. So let's go ahead and we'll open up the graphical calculator and we'll work through one of these examples. So first of all, let's have a little look at the functions that we're going to approximate. We're looking at the cos function here, which is in blue, and we're looking at the sine function here. Now we're going to use the example of 30 degrees. Now 30 degrees in radians is 0.524. So it means that whenever we work out the cos of our 30 degrees, we're going to get this value 1.14. And when we work out the sine of our 30 degrees, we'll get this value 0.548. So these are the actual values that we are trying to get to. So let's go to the graphical calculator and we'll run the simulation. So as a reminder, we have our hyperbola here and we have our circle. Now whenever we adjust the circular angle, you can see the circular angle in blue. Now the equivalent point here on the hyperbola is this point up here. And the length here, so the x coordinate, is going to give us the value of our cos. And the y value here, which is the height, is going to give us the value of our sine. So this is our cos and this is our sine for this circular angle. And remember, we can increase that angle all the way around to 180 degrees, and this line here tends towards the asymptote given by y is equal to x, and whenever we move it round the other way, you can see when we go round to minus 180 degrees, then this will tend towards the asymptote y is equal to minus x. So this is a bit of revision, we've seen this previously. So now what I can do is I can set this to 30 degrees, so that's it sitting at 30 degrees here. So at 30 degrees we're expecting the output for the cosh to give us a value of 1.14, and we're expecting the sine to give us a value 0.548, and these two figures match up with what we've seen in the previous page. So now what we want to do is initialize the simulation. So we want our value for x0 to equal this 1.20749. And the y value is going to equal a value of 0. So you can see we've got this pink vector here. Now what we're going to do is we're going to increase the angle here of this vector, and then we're going to compare it to the angle of the vector in brown, which in effect is the vector which maps to the hyperbola. So we're going to increase the angle, and you can see in this instance when you look at it we've gone too far, so we're going to have to subtract off the next angle, and you can see we're now too far in the other direction, so we'll have to increase this, and so on and so forth. So I'll just go ahead and finish this off. So now you can see that the actual value for the cosh is 1.1402, but our approximation is 1.1407. And the actual value for the sine is 0.5479, but our approximation is 0.5481. So let's go ahead and we'll plot these values, and we'll see them in the actual sine and the cosine curve. So here is our actual point for our cosh, and here's the approximation in pink. And here's the actual point for our sine, and here's the approximation in pink. So you can see here, if we zoom in, this is our approximation. And again, if we zoom in here, this is our approximation. So this process does work, and it does give us a good approximation to the sine and the cosine function. So that's all for this video. Thank you for listening. I'll get you on the next video. Goodbye.